Hey guys, today we're going to be looking at the definition of the derivative, and we're going to practice not necessarily writing out the definition and using the limit definition to solve for a derivative, but more recognizing it when you see it. So a lot of times on the AP test in the multiple choice section, they will give you a limit, and sometimes if you can recognize that it is the definition of the derivative, what can happen is later when we learn shortcuts for the derivative, you can, instead of solving out the limit, just use your shortcuts. So we're going to practice that first, just recognizing it. So for example, I'll do one first for you and then I'll have you guys try one. Given the following limit, identify which definition of the derivative is being used and what your function is that you're trying to find the derivative of. So for example, we know there are two definitions. So the first is the limit of f of x plus h minus f of x all over h as h approaches 0. So that's the probably most recognized and most used definition. And then there's also the alternate form. So limit of f of x minus f of a as x approaches a, like that. Okay, so there's the regular form or the standard form of the definition of the derivative, and then the alternate form. So looking at this limit, first and foremost, can we identify which one it is? I would say absolutely it falls underneath the standard definition form. And then from there, you're trying to figure out what your f of x function is. So the piece that I look at the most is this first chunk, just because, as you'll see in some examples later on, the second piece could sometimes be simplified or not unnecessarily, but it could be simplified and it might be harder to identify what your function is. So if I look at the first piece with the x plus h in it, I know that my function, right, that my regular function would just be my cotangent of 3 times my input. So if I was going to identify what f of x was, I would say cotangent of 3x. Okay, so let's go ahead and I'll look at another one for you. I want to find one where, oh, here we go. So in this example, when I'm looking at my two definitions of my derivative, right, this is the one where I have f of x minus f of a. So this looks more like this form. So I would say that this is the alternate form as x approaches a. Okay, and then you're trying to identify what your f of x function is. And so I would look at here and I would say, I believe my function that I'm trying to find the derivative of is sine of x. So f of x equals sine of x. Awesome. All right, so I went ahead and I did one example of each of the forms. So now we're going to go back and I'm going to have you guys try it. So go ahead and try this one. All right, and now that we're working through it, so I recognize that I have an h approaching 0, so I know that this is standard form, right? F of x plus h minus f of x all over h as h approaches 0. And then my function, like I said, I always like to use the first chunk. It's f of x plus h is my x plus h is my input, so my input cubed would be my function. So f of x would be my input cubed. So that would be the function that I would be trying to use the definition of the derivative for. All right, we already talked through that one. All right, go ahead and try this one. All right, and now that we're coming back, so this one to me looks like it's more the limit of f of x minus f of a all over x minus a as x approaches a. This one's a little weird because it looks like they flip-flopped your variable and your input, or excuse me, your number that you're approaching. So like in this scenario, 65 is my a value. So they went ahead and it looks like they flipped these around, but that's okay because even if I flipped these around on the top and the bottom, you would still get the same answer, right? As long as you do the same thing on the top and the bottom. So it'd be like if I reversed those pieces and also reversed those pieces, it wouldn't really matter. Okay, so identifying here now what my function is. So my function, my f of x that I would be trying to find the derivative of is, it's going to look a little bit weird, but p of t, right? That's the function piece that I'm trying to find the derivative of. All right, let's go ahead and take a look at this one. Okay, hopefully we can recognize that this is my standard form, right? I have an f of x, wow, chaos, plus h minus f of x all over h as h approaches 0. And so then looking at this, my first chunk, it's my function of my input, so my f of x is ln x, and that's what I'm trying to find the derivative of using the definition. All right, let's go ahead and pause on this one. And if we try this one, so this one also is standard form. And then my function that I'm trying to find the derivative of is, I have, using this piece, my sine of 2 times my input. So sine of 2 times my input. This would be the function I'm trying to find the derivative of. All right, let's go ahead and look at this one. Okay, so this one's looking a little more complicated, and this is why this is going to be the first one where I really show you that it's important that you use the first section to determine your limit. So first of all, this is standard form because I have h approaching 0, and I have x plus h's in there and regular x's as well. And I'm going to be using the first piece to determine what my function is because I'm going to be doing f of x equals, so 2 times my input to the 5th minus 3 times my input squared. Now, many of you in our previous examples probably noticed that a lot of times we matched up with the last piece, right? What would be considered your quote f of x over here. But the rough part about this piece is that you'll notice that it doesn't match exactly. And so that's why I said always use the f of x plus h part to determine what your actual function is. Because you didn't know if, like, for example, in this problem, they already went ahead and distributed a negative. And so that would have mucked up your answer if you had been trying to identify what your f of x function was. Okay, so use the first piece with your inputs here. All right. All right, let's go ahead and look at this one. This one was a little tricky because you got x's and h's going on, but it's nothing we can't handle, right? So our standard function form of the definition would be used here. And then I'm looking at this first piece, and it looks a little bit funny because they switched around my h and my 2, right? So like typically, if I was going to write this out, my f of x would be ln of x plus h is my input plus another 2. So my input plus another 2. They just went ahead and they flipped around this 2 and this h to try to confuse you because that's what calculus does sometimes, okay? Oh, and then last but not least, so given this following limit, identify which definition of the derivative is being used and what f of x is. So for this problem, it looks like we have the alternate form because I have x approaching a value, and then I'm finding f of x minus f of a. And so then I would say that my function that I'm using to do this is cosine of x, right? That's my f of x piece that comes first in the alternate form. It looks a little bit funny because you don't actually see f of a, but if I was going to write it out, I would have the limit as x approaches pi, or that would be my a value in my alternate form, of cosine of x minus cosine of pi all over x minus pi. And then you see how they went ahead and they simplified this. Cosine of pi is -1, so minus -1 gives me a +1. So use very specific pieces of your limit definitions to determine what your function is. So I use, for our alternate form, I use what f of x is, and then for our standard form, I go ahead and use the x plus h piece to determine what my original function is that I'm trying to take the derivative of. All right, thanks for working with me, guys.